Oh, okay, great. Let's get started. I think several of you were in the previous talk. My name is Amit, and I work at Google. We spent a lot of time last year looking at performance and latency for Google applications, right? So even on the broadband, even on just for those of you in the previous session, so looking at performance and latency for Google products, right? And generally, Google is known to be, at least for certain flagship applications, pretty fast, right? We pride ourselves on Google.com to be really fast. So I just wanted to talk about some of the lessons that are publicly known as well, and not just Google specific, and some of the tools that I used to actually help look at performance and so on and so forth. So without further ado, it turns out that a lot of time, right, is spent on the front end. So I know there's sessions on optimizing backend performance, on making sure your backend architecture works really well, but at the end of the day, what you deliver to the browser on the client is really important in terms of how the user is spending their time. So here I have some numbers for time spent on the front end in terms of a cold cache. Let's say you start your browser, clear the cache, and try to load, say, google.com or yahoo.com or facebook.com, and what happens when you do it when you have a primed cache, right? So you'll notice that for search, for Google as well as for MSN Live, if you have a primed cache, right, it's instantaneous, right? Because we make sure that whatever is on the Google homepage loads really, really fast. And by the way, this is going to get even only more important as you're in slower countries with slower connections, bad network, etc., etc. So my assertion is, at least the one very simple takeaway, one of the takeaways from this presentation is, pay attention to front-end performance. It's really important, and it's only going to get more complex as you add more Ajax-y stuff, as you add other things, because from a user's point of view, that's where they're spending a lot of time. You have a comment?
I was going to say about caching in Thailand, and they generally kind of ignore all the rules. So if you're developing an application, you have to kind of not cache in order to make sure your users get the right version. For instance, the other day we work on Google Groups for planning BarCamp, and I went to send an email, and Google told me I was logged in as Sajal over there, and I had all these details. So that's clearly probably not a Google problem, it's probably a caching problem in Thailand, but it's very hard to cache well.
So I think that's an interesting point, but no matter what, if it weren't for these problems, from a pure application design perspective, from a web front-end perspective, caching stuff in your browser front-end, right, it's the simplest and like the biggest win, right, sort of when it works. So if there are nuances where it doesn't, that's sort of another point. So again, point number one, 80 to 90% is on the front end, so focus on it. And then there's obviously stuff you can do on the back end and so on, but I won't really get into that too much. So the next thing is, I have literally like 2 or 3 more slides, but I'll actually show some demos and of some of these tools that I have used to help improve performance for products at Google. So there's a lot of things here, so don't try to read sort of all of them. I'll walk you through each of them sort of really quick, and then we'll jump to the demos where some of these things will make more sense. The first, sort of the most obvious one is, make fewer HTTP requests. So we'll do a pop quiz. How many HTTP requests do you think are made if I go to www.sanok.com, SANNOK.com? Take a guess. Cold cache, so it's not a warm cache. Few hundred, says the SEO guy, he studied it. Other people? Okay. So this is like the single easiest, simplest thing you can do in terms of sort of from a front-end performance perspective is figure out how many HTTP requests you have and try to optimize that. And I'll show you at least some of the tools that I have used to do that. We talked already about caching a little bit, but use a content data network, right? So I don't know if folks like Akamai and others are out here, but use some sort of a network where at least for things that are static images, things that is a static code or whatever, JavaScript that you don't really change that often can be delivered from a content delivery network. It makes enormous sense. So these what I'm talking about are very, very low-hanging fruit that will take you literally matter of, from a programming point of view, it's not even hours of work to do. Add an expires header, right? This is shocking, where even for something that doesn't change that frequently, just in the HTTP protocol, there's an expires header, and people don't use that, or use that with either some default setting or something that's very frequently needs to be refreshed by the network. gzip components. This becomes really important if you're even doing application development, especially for platforms such as Open Social or Facebook, or I don't know if people have gone and built Twitter, APIs on Twitter. Making sure that whatever web component is being delivered from your app into the framework of the hosting application, whether it be Facebook or Orkut or what have you, is gzipped, right? Because what will happen is, even though the original application may be pretty fast, say in the case of Facebook, if you're not delivering your app in a gzipped fashion, you're basically going to lose. So there's some very simple headers that you can use in addition to actually zipping it on the server side. The next one is very interesting, and this was from one of my colleagues who's now at Google but used to be at Yahoo. In fact, all of this material is stolen from him. His name is Steve Souders. Is putting style sheets at the top. Anybody have a sense for why putting style sheets at the top is a good idea? Why should you put style sheets at the top of your web page? I'm sorry? Absolutely, because you can incrementally start rendering the page. So from a user experience point of view, the challenge with latency or performance is, if the user has no clue of what's going on, they're waiting, and nobody goes and reads the little bar at the bottom of the page which says loading or waiting or whatever. Whereas if you put your style sheet up front, the page will start rendering itself, right, incrementally. So you'll notice the difference between sites. Once you go back later, you can go look at the view source on HTML and see where it's progressively loading versus where it's not. How about the next one? Put scripts at the bottom. Why do you want to put scripts, JavaScript or other stuff at the bottom of your page? Correct. So that's true. And the point the gentleman in the back made is, because the script is going to do something once the page is rendered, but just as importantly, depending on the browser, right, whether it's IE or Firefox or what have you, there's different behavior on what they do with scripts. So if you put a bunch of JavaScript in the middle of a page, it'll actually block trying to parse the JavaScript, which is one of the most expensive operations. If you've ever tried to parse XML or something like that, it's almost of that magnitude, and block rendering anything else while that is happening. And if you have a bunch of JavaScript that is even cross-referencing each other or calling functions, then God help you, because you could be blocked for several seconds. I'll actually show you examples. I don't know if Sanook has this or not, but we can try some other sites where you'll see in one of the tools that's publicly available how you block waiting for JavaScript to execute. I'm not going to go through all of these. The next, let's look at number 9, DNS lookups, right? I'm actually stunned. I don't know if it'll happen. I was trying this at lunch, just before lunch for Sanook. I found that just to look up Sanook, it took a bunch of different DNS lookups, and each one of them was very expensive and very slow, right? I don't know why that is. I didn't have time to analyze that, but perhaps once we project it here, we can take a look at it. So make sure that if you have differently named domains, if you are serving content from different entries, that the DNS lookup is not expensive. And just to tell you how importantly we treat this at Google, we have a product called Local Business Center. I don't know if it's launched in Thailand or not, where a business can go and list themselves on Google, right? So I can say I have a pizza place and I'm located at this address and this is my phone number and this is my website. We have a really long URL for it, right? So we have some, google.com/local/localbusinesscenter/blah, right? And we were trying to change that to a vanity URL, right? Like google.com/LBC or something like that. And one of the VPs who's been there at Google, like, employee number 9, first female engineer at Google, who's responsible for user experience at Google, Marissa Meyer, she actually would not let us launch that because that would require an extra DNS lookup, right? And I'm thinking, this is a business in India. The damn page probably loads in 10 seconds. An extra DNS lookup is going to be, a matter of, not even tens of milliseconds, but we couldn't do that. Sorry, you had a comment? No, so maybe it was something on google.co.in, or maybe it was just a pure vanity URL or something like that, right? But it was basically, it would have caused a DNS lookup and a redirect. right? Both of which would add at least tens of milliseconds, if not hundreds, but that's really important. Another example I'll give you is, no, actually, let me talk about the next one. Was there another comment in the back for DNS lookups? Minify JavaScript, right? In fact, there's a lot of people who will even minify HTML, but then it makes it hard to read and to do stuff. How many of you have done minification? How many of you are front-end developers who develop applications? Nobody's front-end developer? Okay. How many of you have done, how many of you know what minification is? 2 people. So minification is basically you just take the code and you rewrite it to get rid of white space, to get rid of long variable names, things that make it easy to program, but will make an expensive payload when it's trying to deliver that page to the web, right? So there are tools that can help you minify JavaScript, HTML, even for that matter C++ code where it makes sense. The next one is avoiding redirects. Redirects is one of the most expensive operations on the web, right? In some cases, so if you go to, I think it was in one of your presentations yesterday, vanity URL which actually redirects you to something regular. Well, that's probably great and useful and valuable even if you're paying that extra penalty. But once you're at the site that you want to be at, if you're redirecting people just within the site, that's really, really bad. So for example, for Gmail, if you go to google.com and search for Gmail and then click it, then you go to mail.google.com/mail, there's a bunch of redirects that already happened, right? And I actually try to show it to you show you how much time it takes for each redirect for something very simple, right? So if you again go back to how the user is doing it, why people do that, don't ask me, but people go and type Gmail on the Google search box, then look at the URL, then click the URL, then go to Gmail, then go to login. By that time already they've burnt like order of 10 seconds, right, before they've even entered their password to go see their email. Okay, so now let's, I think people that are in the back may have some trouble seeing this because I'm not sure this is projecting well. So let me take you through some live examples of what tools I use. Can people see this okay in the back? Okay. So this is, so I'm going to go to sanook.com. Wait a second. Why is this? This is not projecting fully. I don't know why this is not projecting. Let me try to see if I can get it to project here in a second. Okay, so now I'm going to go to this site. Let me first, sanook.com, okay. So the tool that I'm using is called HTTP Watch, HTTP WATCH, and what it does is basically it's like an HTTP proxy where every request you made will go through HTTP Watch and it will capture how much time is getting spent for waiting, for being blocked, for number of bytes being transferred, for the initial connection, for cookies, what have you. So now I'm going to just type enter and look at the activity that's happening, okay, and we'll go look at this in detail. But this is just loading the page. This is first page of apparently what is the most popular site in Thailand. Okay, so if you look at the, you can see that over there, 308 requests. Somebody said 100 for the number of HTTP requests that are made. And this is admittedly cold cache, so not the sort of most common scenario for people that have computers or in cyber cafes. But and then you would start, and still going on, right? So of course the page is rendered, but let's go look at this page and do some interesting things. So look at the number of images that are being downloaded. Fortunately, if I look at it, it is being downloaded from a static domain, so that probably is not a DNS lookup. Let me go up to the top, and I can go. This is a pretty interesting tool. So I mean, I just want to leave you with the thought of the tool, but let me just play with it for a second here. So if I go and see where is the most time being spent, right? Oops, can't see this clearly here. So let's look at any given operation. So this is an operation which is getting a static image, which is a little picture over here, right? So you might not even notice it on the site, but it's an HTTP request. It is just 155 bytes, the whole request. Probably not a DNS lookup because it's from the same domain as static.sanook.com, so that's already done. And if you look at the time, you can't see the colors from the back, but this little section here is it blocked waiting for something else to happen while it loads this image. Now the same thing will be true out here, right? So the next one is also about the absolute time is not that critical, but there's a gazillion requests for loading static images. Now one of the simplest things you can do for something like this is you can create an image sprite, right, for all these little images. So like the next one, the image is this, just a little graded, gray. I don't know, it must be a site. I'm not a user of the site, so I don't really know. But look at the kinds of images, each of them, that little question mark with a bubble. Everyone, and imagine how many users Sanook.com has in Thailand, and this is every day this is happening, right? Like every minute. So you can basically go and make a sprite out of this. So it's one HTTP request. You basically kind of give XY coordinates to get that image, and much faster operation. And if that sprite doesn't change that frequently because you don't have hot or something hot off the press kind of thing, it could probably be even in the browser cache, right? And of course, most of these are must be in the browser cache eventually. So this is one example. Another thing you can do is let's look at, instead of images, something else. So do they have JavaScript? Okay, here we go. So here's an example of JavaScript, okay? And in this case, I think they're doing some good stuff, but maybe I'll sort it by size. So here's a big image. So this is the one of the JavaScripts. It's only 4K bytes, roughly speaking, if you can see it from the back there, and it's been compressed to get about 1.5K. But you can go look at it. In some cases, you'll see pieces of code such as this, which is about 20 kilobytes, right? Now imagine if you're on a slow connection, or you're trying to get this page through a WAP transcoder on your mobile phone for 20 kilobytes. It's going to be really, really expensive. To get this. Notice how many JavaScripts they have, right? I can't even count, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. They have 11 JavaScripts, right? Just on the home page. You could probably combine some of these. You could probably go and look at minifying some of this. So I don't really understand all of this, but for example, this could totally be minified, right? So this is obviously some developers written the code, and it makes sense from a dev environment point of view. It's horrible from a performance point of view when you're delivering it. It's small, it's 3.5 kilobytes, but literally you have to pay attention to every byte, every HTTP request, every DNS lookup, etc. So that's one tool. Let me switch to another tool. So on Firefox, you have a tool called YSlow from Yahoo. Yahoo, like Y slow, SLOW. It basically helps you analyze a page, right? So I'm now again going to go to Sanook.com, okay, and I'm running this. So you need Firebug and YSlow. It will take you literally like 60 seconds to install Firebug and YSlow, and then once you run it, what you can do is so YSlow, what it does is it basically goes and looks at the various elements of the page and tells you from a performance point of view what grade it will give to what thing. So for example, how many HTTP requests and so on. So I'm now going to go click this. Okay, so now it's going and analyzing that entire page and trying to figure out what is working well for this page and what isn't. So like we already noticed certain things like the JavaScripts were different and not combined. Some of the sizes of the content was very large. There was a bazillion GIF files. I didn't even count how many HTTP requests, but there might have been like 50 HTTP requests just for images, etc. So look at how many F grades, right, it has. And again, my point is not to poo-poo the site. I mean, it's probably a good site, but the point is that you have to really, really pay attention to performance. And you can do this. I mean, of course, I have a paid version of HTTP Watch. It's not a Google product. It's some company in the US that makes it. But there's also, at least for the popular sites like Google and eBay and Live and Facebook, I think you can analyze it for free. If you just want to play with the tool before you pay money to buy it, you can. So look at how many. So this page has 47 JavaScript files. They don't even go on to say how many HTTP requests. 50 CSS background images, right? I don't even know how the browser would actually process 50 CSS images for one page. The next one was the point about caching that we had talked about. So what are the various things that are not being cached, or could be cached, or could be served from a static domain? We didn't talk about expires when we looked at it. There are many things. For example, let's see, there's a bunch of code here which might change. Is it all code, or is there any like images, or even if there's code, if there's a piece of code which is not something that, okay, so this will change. Let's look at it to see. I would not be shocked. Okay, here. So this thing is not going to change. I don't know what this is, right? What is it? Sorry. Yeah. So but my again the meta point is there are many things that won't change, and for you to use an expires header, even if it changes, if it doesn't change that frequently, if it changes every couple of weeks or a couple of months, or sometimes maybe it's a annual thing or whatever, you can go easily set an expires header. So look at the code is harder to do. Look at the number of things. Even a style sheet may not change that frequently, right? So now every time somebody, I don't know how many page views they get in Thailand, every time somebody requests it, if the expires header is not set or set to some default value, they're going to go fetch that from the network through the cache to their browser, etc., etc. And by the way, to be sure, we're running this cold gzip. So we didn't obviously notice that, but they have files such as this. Look at this. So this is not served gzipped, and it is about, I think it was 28 kilobits, if I was not mistaken. 28.4K just for this file, right? You can easily probably get 60, 70, 80% compression on this file. So now if you go add up, I don't know how much the total number of bytes were. If I go back to my IE and see the total number of bytes for that page, it was about 35K, I think, compressed, right? So if that was truly not compressed, that's like 20K or 25K just coming from that JavaScript, right? I think DNS lookups. I think you had the point about DNS lookup. Let's see which ones they're doing, and then we'll take some questions. Hang on. Look at, oh my goodness, look at this, the number of domains that you're using. Sorry. Yeah, so I don't know what this is. That's all the thing, yeah. So this is Yslow on Firebug. At Google, we also have some of our tools, but those are not publicly available. These two are available for anyone, Yslow and HTTP Watch. I don't know that there's a free version, but only for, as I said, the popular website, so you can go play with it and see if it kind of makes sense in your context. Anyway, so to conclude, since we're going to run out of time like in 3 minutes, very, very important, when I started my talk by saying front-end performance is really important, and I've now hopefully shown you even with an example of Sanook. And there's a little bit of a marketing angle here, because I did it on a non-primed cache, right? It was a cold cache. But even if you do it on a warm cache, you will notice that if I go refresh this page, it's still going to be a while, and it's still going to be gazillion requests. So look at this. This is on a warm cache. A bunch of stuff is getting done through the cache, but you're still getting So the cold cache, we got 308 requests. Even on a warm cache, we got 174 requests. So every one of you, that every time you go to the site, you're doing 174 HTTP requests. And that's only the tip of the iceberg. Sorry. Oops. So, so front-end performance is important. Pay attention to it. There's a lot of low-hanging fruit that you can go and fix with some very, very simple techniques. Hopefully, I've shown you that. With that, I want to thank you and open it up to any questions or comments that people might have.